Welcome to today's webinar, Metals Reimagined, Sustainable Production Techniques for the Metal Fabrication and Manufacturing Industries. This webinar is sponsored by the United States Environmental Protection Agency. I want to thank all of you for taking time out of your busy schedules to join us. My name is Jen Jones, and I will be your host today. We're very excited to have two guest speakers join us today. First, we will hear from Jean Anderton, the Safety and Environmental Director for Franklin Industries. Jean holds a bachelor's in safety management from Slippery Rock University and has served as the chair of Franklin Industries' Joint Health and Safety Committee since February of 2022. Our second presenter, Chuck Haney, is an EMAP consultant with the Small Business Development Center. He specializes in air emissions regulations and works with companies to calculate emissions, identify which regulations apply, and provides practical solutions to achieve and maintain compliance. And again, I am Jen Jones, and I am PennTAP's North Central Regional Advisor. Before we begin, I have just a few quick items of business to cover. If you have any technical difficulties accessing or hearing the presentation, please use the chat pad and we'll try to correct them promptly. The presentation will last approximately 40 to 50 minutes, followed by a question and answer period. And we're going to wait to answer any specific questions until that time to allow us to move through the material efficiently. If you have questions after the webinar is over, please send them to us via email to pentap@psu.edu. And this webinar is being recorded and will be uploaded to the PennTAP website at a later date, and you'll receive a follow-up email notifying you when it is available. So before I turn it over to our guest speakers, I wanted to talk to you about the importance of benchmarking your current consumption and then completing measurement and verification as you implement projects. And this goes beyond just energy consumption. You can benchmark water consumption, wastewater, scrap, material use, anything you use in the process or that is generated as a result of the process can be benchmarked. You can't possibly know what you are saving if you don't know what you are consuming. In fact, benchmarking not only allows a company to determine their baseline consumption, but it also allows for the identification of significant users of the source being benchmarked and prioritization of upgrades or other conservation projects. For example, we were able to determine the energy consumed to heat processed water at a plant in northeastern Pennsylvania, since the boiler used for water heating was the only natural gas consuming unit used in the summer. As you implement projects, continued measurement and verification can also allow a company to prioritize those projects based on the expected savings, simple payback, or other key measures your company may use by allowing one to calculate the expected and actual savings from implementation. In addition, anomalies in consumption can be identified quickly, allowing for early intervention. For example, you can obtain interval data from most electricity providers. This data shows the electricity consumed at a facility every 15 minutes and can be used to identify spikes in consumption or even equipment being left on when the plant is closed. There are several free tools available to help a company to benchmark consumption and conduct measurement and verification. Energy Star's Portfolio Manager can be used to manage energy, water, waste, and greenhouse gas emissions. Measure can be used to determine the savings for projects related to pumping systems, process heating, and steam systems, to name just a few. Then we have the DOE's 50,001 Ready Navigator, which provides the framework to determine baseline energy consumption, significant energy users, and to create an energy management system. One of our clients recently told me they used that program and applied it to do the same for their on-site water consumption. And then we have the EPA's Waste Reduction Model, or WARM, which is available to help with waste management planning. And the EPA also offers several greenhouse gas emissions calculators. As a follow-up to this presentation, we will be providing a flyer that provides a list of several free tools and calculators, how to access them, and how they can be used. Now that you know your baseline consumption and have identified your significant users, what projects should you consider? We all know of the low-hanging fruit, such as LED upgrades, compressed air leak detection and repairs, or insulating steam lines and condensate return lines. But what about the projects that may not be as obvious? Continuous improvement projects result in more efficient use of your equipment, resources, and materials. Creating a value stream map of a product, family, or process will allow you to identify areas of downtime, bottlenecks, rework, and waste. Each of these issues can lead to increased energy and water consumption, wastewater and pollution generation, and hazardous consumption and disposal, all while reducing productivity. And keep in mind that reduced productivity can lead to overtime hours to meet customer demand. This means that all equipment, including your lights and forklifts, are in use for the duration of the overtime shift and are consuming energy and all other process inputs. Oftentimes, there are simple low-cost to no-cost ways to improve your process. For example, eliminating waste and downtime can be as simple as changing your production schedule or making it more apparent. Reducing rework and idle time will serve to prolong the life of the equipment and reduce your maintenance costs while reducing your energy consumption, greenhouse gas emissions, waste generation, and other key performance indicators. We recently worked with a metals manufacturer in northeastern Pennsylvania, where a value stream map was created for one of their product families. As a result of the recommendations made, they were expected to save approximately $67,000, which was equivalent to about 178,000 kilowatt hours of electricity saved and a 26,000-pound reduction in hazardous waste. All of this was from eliminating downtime on their equipment. At a bottling plant in the same region, adjusting their production schedule allowed them to reduce the wastewater generated by 968,000 gallons. Metal processing often involves the use of solvents, lubricating agents, and other chemicals that may be toxic. So what can you do to prevent pollution and conserve water as a result of using these agents? Well, mechanically pre-cleaning the parts prior to finishing reduces the contaminants entering the finishing solutions. This will not only prolong the use of these solutions, but will reduce hazardous waste generated. You can reevaluate the parts that you are currently degreasing to determine if it is necessary. And believe it or not, you probably don't need to degrease all the parts you are at the moment. If flash rusting is not an issue at your site, you may want to consider extending the amount of time your parts are allowed to dry by installing racks with a collection system beneath. The collection system will then route the finishing solutions back to the proper process tank, allowing you to reduce the amount of solution used. And remember, always keep your chemical and rinse baths covered when not in use, and monitor the pH and other parameters daily to prolong their use. If the bath is heated, covering the baths will also serve to maintain the required temperature, which reduces the energy consumption required to heat them. Reducing drag out can prolong the life of plating baths and reduce water consumption and contaminants in the wastewater. Several techniques can be employed, including spray rinsing, increasing the drying time as previously discussed, and optimizing the bath concentration and temperatures, to name a few, to help reduce drag out. Reverse osmosis can be utilized to remove metals and other contaminants in the rinse baths, allowing for water reuse. One of our advisors is currently working with a metal manufacturer that uses one of these to recycle water and reduce the wastewater generated. Similarly, ion exchange technology can also be utilized in the same manner. And don't forget, switching from toxic chemicals to safer or green alternatives can also decrease the waste generated at your facility. There are several non-toxic cleaners, degreasers, and alternatives to other toxic chemicals you may be using that are available through the EPA's Safer Choice website. And now I will turn it over to Jean Anderton of Franklin Industries. Jean will be discussing the energy efficiency and pollution prevention measures they have implemented and the benefits they realized as a result. Jean?
Thank you, Jen. And I just want to say before I get started, I appreciate this opportunity and I think it'll be a valuable learning experience for me as well. So I started here at Franklin Industries in February of 2022. So I've been here just over 2 years. And for this presentation, I focused on some of the more recent improvements that we've made here. Um, we're located in northwestern Pennsylvania, and that picture you see right now is just a nice little overview. Our media manager here filmed or shot with his drone. But that creek in the background is a creek near and dear to my heart. I'm a Franklin, PA native, and that's French Creek right there that we're located right next to. I used to float by it when I was a kid and wonder what they did up there. Now I'm here. So you can go ahead and go to the next slide, and I'll talk a little bit about what we do here. So we are a rolling mill. One of the few still around. The processes here are very old, and we've made some improvements over the years. But a lot of the equipment and things like that is still pretty old, but it works. So yeah, we've been in service since 1901, and what we do is take railroad. We're basically a giant recycling plant. Take railroad rail that's been used and then fabricate it into highway posts and farm posts. So that picture you see on the bottom left there, that is in our yard department. And those are all rail that we have purchased to be rolled through our mill and turned into the far picture you see on the right. So the first picture there of a post is a highway post, and the second one is a farm post. The picture in the middle is just a little snippet of our rolling mill. So all the rail is brought in mostly on freight, like by truck, some on railroad car, and then it is broken, stacked up, stored like this. They pick it up, put it onto a conveyor, and it goes through our rolling process. So that picture is just a little snippet of when the rails cut it into 3 different sections. I don't want to get too technical with the process itself, but you can see from the picture there, it's an old technique. It still works. So yeah, we have 7 departments here, which is pretty important to cover. There's our main heart of the process is the furnace, so that's our mill department, and then we have a production shears department where we cut the material to length, and then it is shipped to either our highway or farm departments to be finished, painted, punched, banded up, and then shipped out of here. Go ahead and go to the next slide. So I was speaking about the furnace. It's kind of the heart of our whole process here. And just a little bit about it before I get into some of the improvements that we've made on the furnace, I'll cover in the next couple slides. It's a Salem Inc. walking beam furnace. It holds 65 rail at a time. When we get the rail in, they're about 40 feet long. And it's one of the processes we have in the back in our yard department. They have to break them down to 12 to 14 feet for them to fit into the furnace. It heats them up to about 2230 degrees, which is hotter than lava, and they come out every 23 seconds. That varies. A couple years ago, it was 26 seconds, and they've made some improvements to that process. So it sped up our production quite a bit. Go ahead and go to the next slide. So some improvements, and I put 2 things in here. There were big improvements as far as like energy consumption. The first one was LED lighting. It was installed throughout the mill, and the entire facility. I just say mill as a cover all for all departments, but all 7 of those departments I mentioned, they switched their lights to LED. And that picture in the bottom right, you can see that's our production shears department. It's just a portion, about a third of our main facility, and you can see the lights at the top. That project started in 2016, but they've been working on it. I think they're almost all switched over now to LED. And the cost savings, the consumption savings is significant. I don't have exact numbers. But each LED light uses 90% less energy than your standard light bulb. And we have upwards of 300 lights that we replaced. And, you know, they last up to 15 times longer. So that cut down on, before they started doing this, I mean, they were having to do light changes every year. And we have a PM system that that was a part of, and that kind of went away. I mean, they could wait 5 years to replace the lights, and you can see from that picture how high up those lights are. We would have to rent aerial lifts to do some of the change outs, so it was a um, big improvement, big energy and time saving. The manpower to change the lights was a significant a waste at the time. And that was a learning process for them here. They started with looking at like 5-year lights, and then started purchasing those, and then they got a little bit more in depth with it and realized um, and did some comparison and all that, and realized that you know, they could waste less with the 10-year lights. So that's what they went to. So it was a learning process for the people involved in doing that, but that's one of the major improvements that we made. And then so that was it for the lights, but I have also in here about the furnace. Um, the dampers were adjusted, and this was last year, lowering the consumption of fuel and reducing emissions. They found out that they needed to keep a positive pressure of 0.040 inside the furnace, and that led to a cost savings of $5,000 per week alone in natural gas usage. And then another big factor from that is those rail, when they come out of the furnace, the first thing that they do is go through a descaler. It's just high pressure jets of water that knock some of the scale off of it. So we produced 50% less since that adjustment was made. And then we recycle the scale as well. There are two different companies that purchase it from us, and I know one of them makes glass out of it. So everything here is recycled. All the scrap that we produce from the rolling process too is repurposed. Some of it's sold back to the owner of the place. Actually owns a scrap business in Indiana, PA. The other thing regarding the furnace tube that we did was I believe it was last year, they had an outside company come in and look at all the burners and make sure that they tested their efficiency, parts, cleaned the lines, etc., and made sure that all the burners were working, were functional and efficient as they should be, which also reduced the fuel usage cost. And I don't have specifics on the cost reduction or energy savings on that, but it was significant. Go ahead and go to the next slide. So talked about the furnace improvements. Now this picture here is our highway department. So it's one of our two finishing departments that we have here. And this picture, I put all the presses in here because the thing that I'm going to cover is their SimCool station they made. And all of these presses have to use SimCool daily. It helps prolong the life of the punches and dies. I'll talk about it in the next slide, but this just gives you a little glimpse of some of the presses. We have 6 different main presses that we use, and the one in the bottom middle, that was during a tour here, but I'm pointing at the 800 press. That's our biggest press, and that will put out 10,000 posts in a day. If it's running, you know, full speed, it can do 100 posts, or I'm sorry, 1,000 posts an hour. So in a 10-hour shift, it can put out 10,000 posts. And then we have, you know, all different sizes. You see a 756 ton, a 90 ton, and then the other one in the right side is a 400 ton press. All right, go ahead, next slide. So the SimCool station was a major improvement, waste reduction. What is SimCool? Just to start out with, it's lubricant used for all the punches and dies. You'll see on the right side there, that is our group leader that was part of this implementation of the system on the right picture. So what she's holding in her hand is a punch in the right hand, and in the left hand is a die. All of those are used to put the holes in the highway posts, and that's what the presses do basically. They punch the holes in. So I had the 6 presses required daily. Yeah, we have the 990, 400, 600, 750, 756, and 800 ton presses. Go ahead, next slide. So before they got this station in there, and I believe they installed this in 2021. Um, they had to do it all manually. So it was a 15 cups of water to 1 cup of Simcool. I'm sorry, 15 cups of Simcool to 1 cup of water ratio. It was wasteful in a number of ways. They had to mix it manually. It's all done with the machine now. And they had to walk to the bathroom to get the water, which seems like a simple thing, but for the amount of Simcool that they actually use, it was really time wasting. Higher chance of spilling it. They would waste some, and you see on the right there, that is a bucket that they mixed it in, and it begins to separate. So this just kind of eliminated a lot of the waste. Um, and then, yeah, I guess go ahead to the next slide. I talk about the new way that they do it. Uh, yeah, so it's quicker, more concise, less wasteful mixing and handling, but it takes out the human element of it. So that 15 to 1 cup ratio, they could, if they only needed a certain amount, a lot of times they would still just make a 5 gallon bucket, and that 15 to 1 ratio was for a 5 gallon bucket. A lot of times they would just make that, let it sit, that kind of thing. This took that out of it, and people would make mistakes too when they were mixing it, and then have to start over, and it all would end up being put in drums, the waste that we didn't use, and then we have to ship that out of here, which I'll talk about a little bit later too. But overall, it was a 25% less amount of Simcool needed once this was installed. And that is, I just have some pictures of the water line, hard line into it, and the station itself. They didn't have to pay anything for that either. That was, they just reached out to the supplier of the Simcool and they set them up with it. So it was a good thing that the manager and the group leader were, realized we need to make an improvement there. Go ahead to the next slide. So this is my final slide. I have a lot of stuff on here that I wanted to talk about, but one thing here is that first picture is the stormwater collection. So I just took a picture of that. I just did that last week or the week before when we had that big rain. But we comply with all the environmental regulations, and testing the stormwater is done twice a year here. And then we send it off. So we use an environmental consulting company. They're excellent. They're called EnviroThink, and they work with us and help us stay in compliance with everything. But that's just a picture, making sure that the pollutants aren't getting into French Creek. Uh, and what goes along with that too is our waste oil procedures. We call it our waste oil procedures, but it's basically just waste. And I have a little snippet of part of our policy right there, our procedures on the right side. But it's just making sure that everybody's putting the waste in the appropriate locations. They sign it in and out. Everything's tested before we ship it out of here, and it helps us track, how much waste we are producing. And they test it if there's a new form of waste that's generated. We have it sampled through EnviroThink before we ship it out, and it helps us stay on top of it. And then I have our residual waste, 25, 26 hours, waste reduction strategies we do. So yeah, those are just some of the things that we've done here recently. I mean, the Simcool station and the furnace improvements, the lights. Did want to talk about future improvements too that we would like to get to. Solar power has been evaluated here for lighting and power. They realized that it's about even for the return on investment right now for the office, and then we're not quite there yet, I guess, for the facility itself. But it's something that is potentially in the works in the future. And then I just had another Simcool station. They are going to get one at one of their main presses, that 800 press that I showed. That's the busiest press here. It produces the most amount of material posts for us. So they're talking about getting one station there, which would be another lean thing and help reduce the waste. And I didn't mention our PM system, which most places have one, and we are all about preventative maintenance of equipment. I mean, work orders are generated daily. I'm kind of like the overseer of that here. If we have any that are past due, I have to send them out to the managers, and but it's a good system and generates work orders. But the PMs are in there for inspecting airlines and um, all the maintenance things that you could think of. Um, and then another thing that we do here, we have what we call caretakers. Um, and they're actually more like security guards, but they walk around. There's a checklist that they follow, and they make sure that all the lights are turned off in all of the departments, that kind of thing. And that does help reduce any additional waste that would have been caused. I mean, to make sure that the heaters are all turned off, that kind of thing. So, yeah, that's it for Franklin Industries.
Well, thank you.
Thank you.
And now I will turn it over to Chuck Haney from EMAP. Chuck is going to be discussing green paint alternatives and solvent recovery. Chuck?
So yeah, I'm Chuck Haney. I'm from the Environmental Management Assistance Program. We do free and confidential air permitting assistance for companies in Pennsylvania. So Jen and I were talking a couple of months ago about metal companies and sharing war stories. And, we'd mentioned that I'd helped a few companies get out of their air permits recently. So she asked me to join this webinar and talk about kind of some of my experiences. So wanted to talk about reducing air emissions and what I'd seen at some of these types of facilities. So why don't you hit the next slide, Jen? What I often see at facilities that are working with metal, these are the most common sources that I'm seeing, with the painting, plating, so on and so forth. But not all of these sources are really created equal. For example, I have one facility that used 9 tons of welding wire at their facility, and that generated 125 pounds of hazardous air pollutants. The same facility used about 9 tons of paint, and that generated 2.2 tons of hazardous air pollutants. So, different or same amount of raw material that they're using, different amount of hazardous air pollutants coming out. So, really, it's kind of confusing on how much air emissions you're actually putting into the atmosphere. So there's a lot of moving pieces when you're talking about air emissions. It's not as easy to see as some of the water or waste stuff. And to throw in an additional confusion, some activities need to be permitted or at the very least regulated, even when they have very low emissions. So really, you need to know where you stand. It's a lot like the benchmarking that Jen was talking about with the energy efficiency and pollution prevention for the water side of things. Next slide. So with the air permitting, there's a bunch of different levels, and each of these levels, as you go down each level, you're probably saving about $2,000 per year just on operating costs, or as far as costs to the DEP every year. That's going to go up, I believe, next year, another $1,000, and pretty soon it's going to be $4,000 a year, give or take, for each one of those levels. So what you're doing is you're trying to figure out the emissions for the sources on the last slide and find out where you're fitting on the permitting levels on this slide, and using that to figure out really whether or not it's feasible to jump down a step and save yourself some money or hassle in the levels of permitting. Now, let's see. Go to the next slide. So the first thing I recommend is to start with the work practice standards. Before you even kind of evaluate what's available, where you can need to go, is take a look at these types of things that you can do with the work practice standards. These are the free things. They're not going to get you to the levels where you're actually going to see massive amounts of cost savings or move down a level in permitting or anything like that, but they're also going to help you and the employees at the facility get into the kind of the right mindset of making sure that you are aware of where you're losing some of these air pollutants for evaporation and things like that, closing containers, reducing the overspray, and making sure your painters are aware of how their activities can save the amount of paint they're using and reduce the amounts of materials and stuff like that. Replacing the filters and making sure they're installed properly. Things like that, not going to cost you extra money, not going to take a lot of extra time, but they're going to get the commitment to excellence in place before you start putting extra time, the more time, money, and effort into the facility to get the pollution prevention into place. Next slide. I love solvent recovery systems. I didn't have a good place to put it, so I kind of put it in here. Solvent recovery systems is a way to recycle the paint cleanup solvents. You throw dirty cleanup solvents in here, it distills it out, you come out with clean material that you can keep reusing over and over again. And you might have to add a little bit of powder to give it a little bit of extra life, but it's a fairly inexpensive way to purchase a heck of a lot less of cleanup solvents to for cleaning up your paint guns and things like that. And if I remember correctly, these are also eligible for the Small Business Advantage Grant for the pollution prevention that should be coming out this summer or early fall. But this is one area where you can actually, if you're doing painting, if you have enough cleanup solvents that you're purchasing, these are worthwhile to get on site and recycle some of that at your facility. Next slide, please. My next recommendation is to thoroughly test any kind of product substitution that you're thinking of. Talk to your suppliers. Now, I'm kind of focusing on paint here because paint's the most likely thing that's going to trigger an air permit because of the amount of VOCs that we were talking about earlier. It's stuff, hazardous air pollutants. It's a higher concentration of air contaminants. So if you're looking at possibly moving to a lower VOC content paint, so from a 3.5 pounds of VOC per gallon paint to a 2.8 pounds per gallon paint, test it. Try it out. Maybe a waterborne, maybe a powder coat, but don't commit right away without thoroughly testing it. Talk to your suppliers. What I found a lot of times, just like Franklin Industries talked to their supplier of SimCool, and the supplier gave them the equipment for free, talking to the paint supplier about what you have, they've gone through this a lot of times, from the higher VOC to the lower VOC types of paints, or to the waterborne types of paints. They've been down that road before with other customers. They know where the hangups are and what's out there. They will be able to talk to you about some pros and cons. What an experience that I had with one of my clients. He had a very high VOC paint. He had a 4-point something paint. And he wanted to go down to the 3.5. He talked to his paint supplier. They said, yeah, we can do it. Here you need to change the spray nozzle on your gun, and you need to slow down the belt that you're going through your dryer a little bit. And that was all he needed to do. He was able to keep his production at a very comparable rate and significantly lower his VOCs. And that was it. It didn't take a lot of work, but it did take a good amount of testing to make sure that he could keep his quality up. And it took a lot of good conversations with his paint supplier to make sure that it was available. Sometimes switching to the water-based coating could be completely different dryers, could be definitely is going to be different cleanup solvents, and maybe different amount of coats and stuff like that. So whatever it may be, that's going to be based on what you're trying, what you're looking for your finished product, and what your supplier is going to buy or be able to provide. Or maybe you go out and check with different suppliers and see what they're able to do. But please don't go based on their promises of what they say they can do. They're going to give you stuff to be able to test it and see that it meets your own or what you can what you need. Next slide, please. And that really is what I say to all of my clients. You really need to do what works for your business. You want to make sure that when you're looking at pollution prevention, when it comes to air quality, that you're doing it without sacrificing the quality of your product. That it's aligning with your company values, and that what you're doing and you're trying to implement is actually going to get used. As much as I love a solvent recovery system, I don't want it to turn into the proverbial stationary bike that's got the dry cleaning hanging from it in your shop. Okay, I want it to make sure that it's going to be actually get used and not be a waste of money. But there are ways that you can do it that are tried and true. As long as you take the time and effort to see what's actually going to work for you. And that is what I wanted to go over today. So thanks again for having me on the webinar. And if anybody has any questions, my contact information's there. Feel free to reach out.
So before we conclude, I thought I would tell you a little about PennTap and what we do. PennTap is a statewide grant-funded organization housed within the Office of Entrepreneurship and Commercialization at University Park. Our mission is to support Pennsylvania businesses, and we focus mostly on small to mid-sized manufacturers and startups to help advance economic development throughout the state. I'm proud to say that we are celebrating our 60th anniversary and was one of the first technical assistance programs in the country. We do offer our services statewide, and we engage with businesses to improve their operations and drive innovation. We do this through our P2E2 assessments, where we walk through your facility and help you identify ways to lower pollution, waste streams, energy consumption. And then we also offer our E3 assessments, which combine the P2E2 assessment with continuous improvement. We also assist a small cohort of clients to become ISO 50001 ready, and our innovation services assist clients with product and process development and connect them to the myriad of resources available through Penn State and our network of statewide resource partners. In 2023, we helped Pennsylvania businesses achieve $8.4 million in economic benefits across 38 counties within Pennsylvania. We educated over 1,000 individuals and saved or created 26 jobs. Before we conclude, I would like to mention that we are partnering with the Green Building Alliance to host an in-person event in late July that is dedicated to pollution prevention and energy efficiency strategies in metal manufacturing. And this event will include a tour at a metal manufacturer. The event will occur in Western Pennsylvania and is meant to be a complement to this webinar. So stay tuned for more information as we finalize the agenda and send out the dates. So with that, I'd like to open it up to our attendees. If you have any questions, please type them into the chat pod and we'll be happy to answer them. And while we're waiting to actually have anybody ask a question, I did have one question for Jean. When you were talking about the SimCool, what were you guys doing that made your facilities managers take a step back and go, this process is taking too long, how can we make it better?
Yeah, I had to unmute myself there.
Oh, that's okay. Yeah, I don't know how I got muted.
I think they just realized how much time it took because they had like the bathroom where they had to go to get the water was a decent, like, I don't know, I'd say 30-second walk, which doesn't seem like a lot, but for the amount that they use, and I had some notes on there too about like how much they use. They go through I mean, they use a significant amount of it. I think it's 55 gallons of it every. Well, they were using more before they got the station because a lot of it was getting wasted. And I think you realize how much they were generating too, like that ended up just not being usable. So that was definitely part of it. The time it took to fill it up manually to fill up a bucket because they used just a 5-gallon bucket for each time they did it. And it all had to be pumped out manually out of the drums. And it was just a major waste of time. And then they were generating a lot more wasted SimCool from the process. So I don't know specifically when it was the department manager that like initially realized, and it could have been, I mean, we have, and I think a lot of companies do right now and over the last couple of years, the turnover issue. Staffing issue with our mainly our general labor positions. But yeah, there was that. And then there was also the it's involved with that, but the training involved with how to mix it properly. They were having people make mistakes, even though they had it, instructions at the mixing area, and training on it, but they were having people make mistakes. So that station kind of just eliminated the human error side of things too. I hope that answers.
Yeah. I was just curious. One of the things I liked too was your comment of the 30-second walk. When we do a lot of our lean trainings at manufacturers, this kind of goes back to continuous improvement. It is usually the downtime is a matter of seconds, maybe a minute here or there, but that all adds up over the course of a year and very quickly slows your production. So it's good to hear that, you're kind of reinforcing that notion that 30 seconds adds up quickly.
For sure,
yeah, it does.
I was going to add, I'm sorry. Yeah, all of our leadership here is our president's really big on lean, and all of our leadership here has been through at least lean 1.0 training. So that might have been where the manager realized, okay, here's a big waste. It may have been, but they try to encourage everybody here to think lean and come up with ideas like that. And we have a couple incentive programs for that too that I didn't mention before.
Thank you. Chuck, I also had one question for you. What has been the feedback you've had from clients regarding using low VOC paint or water-based paint? We also talk to clients about that, and I'm just interested to hear what they have to say to you when you broach that subject.
Nobody ever wants to do it. So a lot of times what winds up happening is they use whatever paint they want until they trigger a permit from the DEP. And then the DEP says, great, now that you have a permit, we're going to limit you to the 2.8 VOC, pounds of VOC per gallon of coatings instead of the 3.5s you've been using. And then they complain and grumble, and they actually find out that their paint supplier can do it and can do it very well. And then I talk to them a year later and they're like, my gosh, I don't see a difference whatsoever.
Yeah. Thank you for that. That's why I asked that. That I run into the same usually. So
Yep.
I'm seeing if there's does any of the attendees have any questions they'd like to ask before we conclude? We have a few minutes left. All right, well, if there's no further questions, I guess we will conclude today's webinar. Again, if you have any questions, once you go back to your desk or after lunch or anything, feel free to email me, jsm148@psu.edu, or to pentap@psu.edu, and we will answer them promptly. Like I said, we will be sending out a recording. We do have one question. What about clean energy? So I know that Jean discussed solar. Steve, what are you asking about clean energy? Are you asking about success with solar, what we've seen manufacturers use and do? Well, while I'm waiting, so I've worked with several clients, just like what Jean and Franklin are looking into on solar. And solar, if your roof can withstand the panels on it, it can be a great way to reduce your electricity costs. And if you have the roof space available to be able to produce more than what you're using, you can then sell it back to the grid, further offsetting the costs. I always tell clients when they're thinking about any green energy project, especially solar, get your building as efficient as possible. So if you still have a ton of fluorescent lighting in there, you probably want to upgrade it to LEDs before you put in the solar panels. It's not only, potentially reduce the size of the installation you need and the cost, but it can also allow you to be able to sell more energy back to the grid. And then as you're looking at these green energy projects, another thing I always recommend is, are your HVAC units burning natural gas? Could you size the panels, the installation, such that you have extra left over, and then you can possibly replace those HVAC, those fossil fuel burning HVAC units with electric units, and now you've reduced your greenhouse gases, you're using a greener energy. We have one client that's using clean hydrogen, and I'm going to be honest, I would have to find out a little bit more. It's not my client. I know that I just attended the Better Buildings Conference, and there was a session on clean hydrogen, so it is something that is starting to be used more and more. But I'd be happy to get you a better answer on it offline if that would help you. I have only ever had the one client, and again, it's not mine. I didn't get to attend the assessment. So another question we have is, are there any furnaces on the market that are operating using alternative energy sources? And if so, would they be feasible for a metal fabricator to substitute? I have seen, I have one client that's a foundry that actually uses an electric induction furnace, which you could potentially power with solar. I have clients, a lot of our clients actually participate in waste heat recovery so that they can either preheat the parts to reduce the consumption associated with the furnace. There's things you can do such as gate crushers if you're melting metal that allow you to break down the scrap into more even uniform parts, and then you can more densely pack your furnace. But I have tended to see the more traditional furnaces being used, and the alternative energy sources, again, I tend to see the electric furnace, and then they power it with green energy somehow. Are there any other questions? There's also our associate director actually responded to about combined heat and power. So combined heat and power is if you're really generating a lot of heat, and we can send out some information on that. We do have the Mid-Atlantic combined heat and power tap group right here on University Park. They can go in and evaluate your facility to determine if it's ideal. So we can actually maybe include that in the follow-up as well. I'll make a note. But if do we have any more questions before I conclude? Because these are all great questions, and I know we didn't really focus on clean energy, and I apologize for that. I try to focus on using what you already have to a more in a more efficient manner if there's a better way to do it. Well, with that, I guess we will conclude today's webinar. Again, if you have any additional questions, reach out to me or through the PennTap website. We will be providing a follow-up email. In that follow-up email, you will have access to the recording, and we will also include a handout that has several resources available to you beyond the ones that I talked about to do everything from measurement and verification to benchmarking. And again, thanks for attending. And I'd like to take one more second to thank Jean and Chuck for agreeing to present today. You guys gave wonderful presentations and we learned a lot. So with that, I hope you all have a great day and we'll be in touch soon.
Thank you, Jen.
Thank you.
Thank you.